So here's a brief sort of introduction to naming ternary compounds. You guys should be, with a little bit of practice and scraping off the rust, some binary compound masters, which means that you can name compounds with two different elements in it. I think that we looked at them and we said that there are ones called salts, which are made of positive and negative ions. So generally that's going to be between metals and nonmetals. There's also going to be transition salts, which are made of the transition metals, the positive ions, and nonmetals. And then there are also going to be acids, which I think for right now we've defined as sort of like hydrogen and then some nonmetals. Okay, so binary stuff you've already done. You should have been given a list of a whole bunch of polyatomic ions. So for example, I think that there's one that looks like this. They look scary, but the thing that I'd like you guys to do is, this is a polyatomic ion, which means it is an ion made out of many different atoms. But I'd like you to kind of treat it right now as an indivisible chunk. So treat this negative ion, which is called nitrate, and this is all on the sheet you've been given. Just treat it just like it's a -1 ion. So just say it's like chloride, okay? That it's just, this is a big chunk that has a -1 charge. This is a chunk that has a -1 charge, okay? The only things that are a little bit different are about naming. Another example of one, that polyatomic ion is a common polyatomic ion. We're going to treat it just like it's an ion that has a -2 charge. We'll call this carbonate. Okay, this too is on your thing. You should use that sheet and the list of them until you have sort of committed to memory the formula and the charge associated with each of these polyatomic ions. Okay, so there are a bunch of them on your sheet. I'll let you know which ones you need to memorize and which ones you don't. Okay, so ternary, which is just saying these are compounds with those polyatomic ions in them. Salts are still, they're made up of positively charged ions and negatively charged ions, okay? So, for example, this is called sodium, and what's this polyatomic ion? It's nitrate. So, the name of this thing is sodium nitrate. Not so bad, okay? This sodium carbonate. So you just name it sodium carbonate. So the hard part here is really just committing to memory the number of each atom and the charge of these polyatomic ions, okay? How about if you wanted to get the formula from the name? Well, let's do magnesium nitrate. Well, the first thing you got to do is recognize that this is a metal and a bunch of non-metal-y things. So this is an ionic compound. So we're going to put in magnesium. What charge does magnesium tend to gain? Well, you know from your periodicity unit that it tends to gain a +2 charge when it reacts. Nitrate, you've committed to your memory in your brain by doing these so often, that it gains a -1 charge. Okay, what do you know about ionic compounds? Well, you know that negatively charged things attract positively charged things and vice versa, and things tend to end up neutral because if they have a charge, they're going to continue to attract that stuff. So here you would have, how many nitrate ions would you need to balance out that +2 charge on the magnesium ion? You'd need 2, Mr. Gorin. Cool. So the formula of magnesium nitrate is like that. Okay, so you still have to do the same rules that you did before in terms of taking into account generating the formula. That in an ionic compound, it's still going to be, the charges need to balance out, and yeah, so we'll come back to acids in just a second. Okay.